Okay, so this question asks you to find the voltage across the entire thing. So the important thing to know, or like the main idea here, is parallel capacitors and their relationship and how they work. So for parallel capacitors, these two are parallel capacitors, your voltage is going to be the same throughout that parallel. So your voltage is going to be 311 volt. They give you that in the problem. Your voltage 2 is going to be the same as your voltage 3, which is 311, because these are parallel to each other. So then your capacitance for 2 and 3 are going to be just the addition of what they give you. So they tell you the capacitance of C3, and they give you the capacitance of C2. So you just have to add them together, and that would be your capacitance for this part of the system. Then to find your charge, you use your regular charge equals capacitance times voltage. Turn this into times 10 to the negative 12 picometers. And then you multiply your capacitance by your voltage, which is 311. Your charge for 2 and 3 is the same as your charge for 1 because they're the same capacitors. And that's going to be 7.75 times 10 to the negative 9, or nanocoulombs, however you like to phrase that. To calculate your voltage for capacitance 1, you need to do charge of the first capacitor, or charge of capacitor 1, over the capacitance of this capacitor. That's going to be the charge that we calculated here, which is the same as the charge of these two capacitors. And then, so that charge over the capacitance, which is 5 picoforce, right? So to do that, we get a voltage of 1550. That's the voltage of this one. To get the whole voltage of the whole system, we add the voltage that we got from C2 to C3, this voltage in this red kind of square that I drew, and then the voltage in the whole thing, right? The voltage between C1 and C2, C3. So that would be AB, or voltage of AB, I label my points A up here and B here to resemble like the whole system, is 1550, which is what the voltage for capacitor 1 was, plus 311, which is the voltage of C2 and C3. And that gave me 1861. And so come up here, 1861 is closer to 1900, and that's your answer.